Alright, for the final and third demonstration that's on your paper, what we're going to be doing is we're going to take these bottles right here. These are just Minute Maid bottles that I filled, one with fresh water, one with salt water. Now, in class I had them look at these examples and try to determine which one was salt, which one was fresh. They had a difficult time trying to do so. Some kids went back and forth with the differences and if they thought the orange or the green was salt or fresh water. Okay, so I'm just going to show you the demonstration, just real simple. I'm going to pause it here for just a second while I get it ready. Alright, what I'm going to do first, I'm going to take this orange bottle, just putting a card on the top to hold the fluid in, tip it upside down, and I'm going to place it right on top of this bottle here, trying to get it nice and steady. Green one, do the same thing with it. Okay, hopefully you can see how this is working. I can see it good. Alright. Now what I'm going to do is I'm going to pull the cards out here in a second, just really slow. But what should happen, if the orange one is fresh water, it should stay there, because if this is salt water, the green, then salt water is more dense than the fresh water, so nothing should happen. Okay, but whichever one is salt water, the top ones, it should sink to the bottom, wanting to exchange places because of density. If it sinks, as it starts to sink, it is going to mix. This is really important when we're talking about the ocean. All of our stuff needs to mix. If it doesn't mix, we're going to have problems. Okay, so let's just go ahead and show you how this looks. See what happens here. Okay, right away you should be able to see that that's mixing. Okay, working good. So what does that mean? Alright, so this one is not mixing. So that means that my orange bottle was salt water, my green bottles were fresh water. So over here on your right side, my left, the salt water is trying to go to the bottom where the fresh water is because of density. As it moves, it circulates, as it creates this convection current because of density, not temperature this time, density. The more dense wants to sink to the bottom, the less dense wants to go to the top, but it mixes. As it mixes, eventually it can create an equilibrium where everything is going to be balanced. That's important in the ocean ecosystem. If we didn't have that, we would have this problem over here, where we would have fresh water on top, salt water on bottom. That means if nothing is being balanced, okay, then we're going to have an issue where we have too much salt on the bottom, too much fresh water on top, so our ecosystems aren't going to be balanced at all, okay, and they're going to suffer. Alright, hope you guys enjoyed looking at this, and you're going to need to get caught up on your bell work that you missed last time, because those bell work questions tie into what we did here today. So if you have any questions, come see me.